Thank you very much, Markus. Thank you very much also for the introduction, for the invitation, possibility to have this workshop. And I hope it's a little bit of use for some people. Yeah, I start right away because it will be quite dense, the program. So what we are trying to show here is in this workshop, here we go. We built up a kind of a handbook how to use this RDF creation pipeline, and this is splitted into the points you see here. And in our presentation, we will go through these points as well. And we will concentrate on the point 5, the RDF creation pipeline, only mention briefly the other points. So give a short introduction, then show the handbook and the data structure, mention what software components we need to install to do that, what ontologies and modeling we're speaking up. Then we come to the points of the RDF creation pipeline. The thing is put on Zenodo right today in a version 2, and Steve Stead contributed to this version 2 as well with a specific Excel that we created together, and I'm going to show that in a moment. So what is it all about? The RDF. What is RDF for these people who may not know? It's a specific formalization of data, a specific data structure where the identifiers, this is important, they are URIs. So they have this format. You have a HTTPS or HTTP address, and then comes a string. And they are structured with triples, so with the subject, predicate, and object that we see here. And this, there is the next thing. What you can do for the URIs is you can use a prefix to shorten these URIs to make them more readable, because they're not very readable as they are fully expanded. And this triple structure allows us to create knowledge graphs. Through these triples, I add one triple to the next triple, and then I get a graph, which is a different data structure than we have relational tables. And the big advantage of this structure is that I can add new knowledge or new data without changing the structure of the old one. So the initial situation where we start from in this workshop is the idea that we already have tabular data sources or annotated text, or we have data in databases. So we have data in a structured format already. Then there is already a mapping. I will not go into detail of the mapping process, because this is a kind of a different workshop. And our pipeline starts in a way when we already have a mapping, and out of this, with this mapping in mind, we create delimited text files with identifiers. So this is the starting point, the delimited text files with identifiers. And we have this generic sample data. So this is a spreadsheet which would apply to any mapping, and you can encode your mapping already in this generic sample. Already in the Excel, you can encode your mapping and show your mapping also to other people. Or the second way to use this pipeline is you have complete project data. In our case, it's of excavation data. And so these are the two starting points. And out of these points, we want to create this RDF data with its URIs and create a network. So this is the handbook. It got, in the end, quite extensive. You have the links there. We have 84 pages right now. And with this handbook comes also a data structure, data examples. And I show you how it looks like if you downloaded it from Zenodo or you access it on the Google Drive. So the main points is this data and material. And in the material, You have the ontologies as they are right now, as we use them in the data right now. So you have CRM in its extensions created in March of this year. GeoSparkle is there, and then there are some prefixes. And you have the sample data for different samples. We have one for Alpine Magazine, Excavation I'm going to present here, generic CRM. This is the one we will play through. We have a sample for if you build a thesaurus, and Vita, that's the sample Milena is going to present. And then for each of these data, which come from different sources, you have input data, scripts, RDF creation. And the numbering of the directories corresponds to the numbering within the document. So it should be helpful to find your way through. And we will look in the input data, for example, you will find this generic excavation sample Excel. That's the one we are going to play through. And this is the Excel, this is the starting point. And then the next thing to do is that we use SQL scripts with Postgres, and then we do the RDF creation. So this is the structure of the data. I just wanted to put it here on screen that you can look it up later. For the software installation, just telling you that we need 4 software products, a text editor. We use Postgres as a database. You could use any other database as well. Or if you want, you can even skip the database and use other processes to create the files that we need. Then we use GraphDB as a triple store, and we use OntotextRefine as the mapping tool where we put the mapping in. So this is only brief. We use for our modeling here, we use the CIDOC CRM ontology with all this, with the temporal entity in center. And for the excavation documentation, that's the reason I mention it here, we mainly use the observation class, inference class, and on the physical and place side, the site, rigid physical feature, and the stratigraphic unit in their use in CRM science. That means they are all 3 of these classes are subclasses of physical thing as well as of place. So I can attach coordinates directly to the instance. So this is what it looks like, our RDF creation pipeline. We have our input, Excel, tabular data, whatsoever tabular data you may use. You have a conceptual mapping that you did in your mind with Draw.io, PowerPoint, whatever. And then we make this identifier creation, and we do that in Postgres. So we import these tabular data into Postgres and create other text files which contain already the identifiers. Then we load this data into the OntotextRefine, where the RDF modeling is done. And then we connect, there are 2 possibilities. Either you create directly in OntotextRefine the RDF, but this is only a turtle. And if you want to create named graphs or RDFstar, you have to use a specific interface to GraphDB and create a Sparkle query, which we did for the models we present here. We already did the Sparkle queries, but you kind of connect GraphDB to OntotextRefine to get the data, and then GraphDB creates with a Sparkle the RDFstar statements and the named graph statements. So in the first thing is we look at this data entry spreadsheet in Excel and the mapping. So how does a typical Excel sheet in our RDF pipeline look like? We have here we have three sheets in the Excel. One is this generic CRM, One is the prefix, and one is the .tos. I start with this generic CRM and the prefix. The generic CRM looks. This is the Excel that we use for a generic creation of a mapping. Here you see you create the mapping already in the Excel. That you need IDs. You can give to this, in this case, this is a smelting site in Lower Austria, in the Lower Inn Valley of Tyrol. And you have an ID, you can have a label for that thing. You can have the class of that thing. This is a site. And then it has a specific type. And this is the ID of the type. And this is the name, the label of the type. And this is the class of the type. So you see we kind of here in this Excel sheet, we implemented something which is already very close to RDF, to the subject predicate object. But we have, in addition to the subject, we have already the class of the subject and also the label of the subject. Then comes the property and the range of this in the RDF. And to make that thing readable and also writable, we use the same prefix notation that RDF is using. So we use, for example, CRM for the CIDOC CRM. And we put on for our own identifiers, we put our own prefix. In this case, this is a UIBK prefix. So this is the structure of that kind of spreadsheet. And what's the important thing about all the spreadsheet, also the other ones that we use, is that you create your own identifiers, and you have to make sure to make them unique. And this uniqueness you can attain a lot with the prefixes. You use, for example, if you have a database with different tables, which all have identifiers starting with 1, you could use prefixes for each, a prefix for each table. And you have this gives you a lot of power, this sovereignty over the identifiers, because if you have the data set from somewhere else and you know that this thing and this other database is the same as in your first database, you can just assign the same identifier. What this our sheet can do as well is that we have we use so-called in CRM we call them .1 properties. That means that we have a relation of a property to a concept, to a not only a concept but to another instance. In this case, we see, for example, the melting site of Rotholz is composed of a trench, and this trench is composed of 2 different stratigraphic units that we see here. And they have a physical relation, the stratigraphic units. And this relation we attach to the property, to the AP11. We have this AP11.1 has type, and you see here the below. And you see it's in the Excel, it's encoded like that. We have the site here is composed of another physical feature. The physical feature is composed of the two stratigraphic units. And these 2 stratigraphic units, the relation of these 2 stratigraphic units have a .1 property, this target, which is the
I'm wondering why, practices that take decades to master, truly master.
Okay. So these are the .1 properties which are encoded in this Excel as well. So you can represent them here too. And then we have a very specific case in CRM Archaeo. We have so-called .2 properties, which relate to 2 properties. In this case, we have the physical relation and we have the stratigraphic relation. The stratigraphic relation is justified by, that's the .2 property. So the before that the genesis of the stratigraphic unit 22 was before the genesis of the, oh, sorry, it's the other way around. 33 was before 22 because the arrow goes in this direction, and this before is justified by the below. So you can represent stratigraphic relations and the argumentation why you say that this, the genesis of one layer happened before the other layer. Another thing we can do, we have in this Excel is this, we call it proposition set. If you know RDF, then you know you can have contacts or named graph. So for each triple, you can say this is a triple within a specific context, within a specific named graph. And we put that one into a field, this field proposition set. And in this case, for example, where the smelting site, there was an interpretation that this smelting site was used in the years 1300 before Christ, and there was the activity of smelting and this at this site. And we say that that this is an interpretation, and we can put all our interpretations, we can put into a different graph, into a different named graph. And with this, we can also say who made this interpretation, what was it based on, this interpretation. For example, here, this inference, this interpretation was motivated by we related it to the documentation of the site, but you can relate it to a specific observation, to a C14 dating, whatsoever. So in the end, we would have, we created in this CRM excavation, generic excavation sample, a graph like that, where we have these things which are represented in RDFstar, that's the properties. From the properties, we go to a below, or we can even relate two properties to each other. So the workshop data that I already mentioned before, if you download it, you find it here. So these are the different examples. And I'll go now to this generic CRM example. I downloaded it to my local machine to under C. This is on Windows. On Mac, you have to pay a little bit attention with Postgres, but it's mentioned in the documentation. And I put this generic CRM, which is here. I put the same structure down here. And so the next step is to load this Excel, I don't load the Excel, but the Excel was exported into text files, and I load these text files into Postgres. And in Postgres, I create the identifier through replacing the prefix with the strings that are in the prefix table. So what I'm doing, I have to run SQL scripts. You find the SQL scripts down here. You find the input data here in this 5.1. You find the SQL scripts in the 5_3. And I'm using this generic create generic excavation sample database. And now I try to show it, and I hope it will work. So I already opened Postgres not to lose time, and to show you how to get your Postgres script. Here I have the structured generic CRM SQL scripts. I go here in the generic create generic excavation sample database. This is the SQL script. It's simple. What it's doing, it's creating a table and importing the table from a text file. Here the text file. So if you put it on a different place on your computer, you have to change in the SQL scripts. You have to change the path in here in the script. Now of course, if this is for Windows now, and if you are using it on Mac, you have to change the backslash to slash. But most important of all, you have to move your text files to the temp directory of your Mac, because Postgres can only read from that directory, and you have to change the permissions on the files in the temp directory. It's written in the documentation. So then I switch to Postgres. What I'm doing, make it to show you, you see I have a lots of database. I create a new database. I call it whatsoever test2. Unfortunately, you need to do a little bit, you need to know a little bit of databases and Postgres. What I have to do as well, because I'm using geometries in these processes, I have to install the PostGIS extension as well. It has to be done in the installation process, and you have to do it for a specific database here as well. If I click on the database, then with this icon, I can get a new window, and in this window, I just copy the SQL that I just copied from the text file. And ja, das passt. Ja, für Windows passt das schon. Okay, so now I have in my schemas, I can see here, I have the tables. If I never have seen Postgres before, that of course is a little bit a lot. But what I did, I created three different tables in the database which correspond to the text files. The prefix is unfortunately still called E15 from a previous version, and the special reference systems comes from the PostGIS installation. And so the next here in these tables, there's the nice function select script. Then I see what's inside the table, and it's exactly what we have in our text files. So the next step I'm doing, I'm creating my, so you see here, I have here still the prefixes that were in the text file. And the next step I'm doing is I'm going to the next script to create generic excavation sample URI files. So that's script, copy it into Postgres. Just delete that one. Go on execute, and what I see, if I do a refresh now, I got three more. I got three more tables, the URI tables. And what I did as well here, I copied the tables to text files on my local drive. And these text files, they are already for all the sample data, these URI files, they're already created. So you can, if you only want to test the next part of the pipeline, you can directly use the URI files. They are here in the RDF creation under URI files. And you see, these are the three ones that I just created now. So this is the part of Postgres, creating URI files. And you, of course, in Postgres, you can do lots of other things with your data. And if you have complex data, you can do more things in Postgres. And we are doing that in different projects as well. But to get you, this is kind of the easy way that I just showed you. So the next step that we have is, this was the SQL scripts to create the URI files. And the next software element we are using is the OntotextRefine. So we have this URI, we just created the URI files, and then we use OntotextRefine models and later put them into GraphDB. And I'm going to show you that now. In OntotextRefine looks like that. If you install it, you have to, in the install, it's also in the documentation. If you want to do, really want to do your own mappings, you have to import the ontologies into GraphDB first and relate in the setup into a repository and relate in the setup of OntotextRefine this repository to GraphDB. But with the generic CRM, you don't even need that one. Okay, so we create a new project. We choose a file, and here you see this RDF. From the RDF creation, I go to the URI files, go to the generic excavation sample URI. And it shows me the data. So this is the text file I created with Postgres. I say create project. Probably that's the 10th project I'm creating with this name. And now I have this project created. I have to go to this RDF mapping, edit RDF mapping. Now you can do your own mapping, or for the sample data, we already created the mappings. You can upload the format of the mappings. It's a JSON file. And the JSON file you find under this RDF creation, OntotextRefine models. And this is the generic URI mapping. You're going to delete all the previous mapping. So this is the mappings that we have done for this specific data. I have to go to the save. And then you can, if you want to create your RDF just as turtle, you can go here to RDF, convert to RDF, and it downloads a file. The file looks like that. Just open it with Notepad. And this is the RDF that was created out of the text file. So this is the easiest step to create RDF, your RDF. This RDF is not in a named graph. You have to do that in GraphDB. If I want to put this, for example, I want to put this now in GraphDB in the triple store. Then I switch to the triple store. I feel already something. I make a new, for the sake of it, I make a new repository. You see, I have already some. Test 2500. You always in the triple store, you always have the repository. You can imagine the repository as databases in your, if you are working with relational databases. So, and now I have to make active the one that I just created. That was the test 3. And now everything that I'm doing is happening on this test 3 repository. I can here go on import, upload an RDF file. And it didn't, now I have to go to my downloads, get the result triples, open them, and import them. And now it asks me into which context, into which named graph I want to integrate them. And I say here in the data there is no graph. I say the default graph. And if I go on Explore on the graphs overview here in the default graph, I have all my triples. So if I look, for example, I want to go to the main thing, which is that one. And here I can look on with the visual graph. I can see the mapping, and I can, with double clicking, I can expand the mapping and move on. And here here you see already in this mapping I have the dot one properties are not in yet, but I have this. Yeah, because of course the dot here you see the dot one properties of course are not in here because there is no RDFstar created. So this is the difference to the next process that I'm going to show you. But we have the stratigraphic units. Okay, so the next, the other way, if you want to create RDFstar or automatically create, import your data into specific named graphs, is to use the Sparkle interface of GraphDB. The first thing you have to do, you have from this visual RDF mapper, we are now in OntotextRefine again. You have to go to the Sparkle query editor, and then you can either go to Open in GraphDB, what I show you. If I open it in GraphDB, then comes a query, but that's not the right one. I'm sorry. I'll show you the other one. Did I save? Saved. Generate from mapping with service clause. Okay, I have to go to this generate query and then choose from mapping with service clause. And the thing what it is doing, it creates this mapping as a Sparkle statement. And the interesting thing, it combines it to a specific service. This service is obviously implemented by OntotextRefine. So this service provides the data for this mapping. And we have to remember that for this service, there's an ID for this service. And now I go to the Sparkle query window of GraphDB. I open a new query, and I already have Sparkle queries. We have prepared Sparkle queries for that one, which are in this RDF creation. Sorry. Generic CRM, RDF creation, OntotextRefine models. There's one generic CRM Sparkle. And the Sparkle for the first triples for the URI, that is this first one. I copy that, put it into the query window. And now this Sparkle I created was created with a different ID for the service. And now I have to take the actual ID from the project I just created, which is that one, and copy it in here and run. And you see, I'm from the repository. I'm still in the test3 repository. We added 46 statements, and now, if we have a look, we see that in addition to the default graph, there were two new graphs, named graphs, two new contexts were created. And I can look into this. For example, if I go to go straight to the interpretation, and I look here. That's the E2. So this is the smelting activity. So we see that this activity is subject of. So we have the the RDF star created as well. And what else do we have? We have the trench 1. We have the stratigraphic units, and we have the .1 properties created with this. And this was done actually to have a look. Let's look again at the Sparkle. I won't go into too much detail here. It was done by inserting it in a specific graph. This makes opens up the possibility to create my data into different graphs depending on the data that I have. And creating the RDF star statement, it's here with these double kind of brackets, minus, plus, greater than, smaller than signs. You integrate the RDF star statements. Okay, and what you would need to do, we didn't include literals, are not included in the data right now, and the .2 statements are not included in the data right now, and it's the same process doing it now. Maybe I try it. I do it for the .2 properties that you see, that one. So I have to, and that you see the whole process one more time. So I go to the projects again. I have to open. I have to get data. I go to my URI files. It was the .2 URI. So you see this only has one line. To make it another name as well. RDF mapping. I upload the RDF mapping, which is in the RDF Creation, the OntotextRefine models. It's the .2 mapping. I have to save it. Go to the Sparkle query editor, generate query. This is the query I have. What I really need is this identifier here. I go to the graph DB, to the Sparkle window, make a new Sparkle window. I go to my Sparkle file. This is the one with the literals. We don't show that now, but the .2, this is the one for the .2 properties. Error. I did not. Maybe did I saved it. I did not copy. Thanks, Milena. I did not copy the ID. So this happens if you don't copy the ID. Here we are. Okay, that was good. And if I go to explore, I go to the sample. I go here to the stratigraphic Genesis. And I see I've added now this justified by, so this .2 property. And of course, they are all, I have the rest of the graph here too. It's always with double clicking, you come to the next, you can open up the next one. Okay, so that was to this .2 properties. Maybe what's very important, you may get in the process of creating the graph, Here you may get an error here that you have your that there was a wrong URI value. And this can happen if in your identifiers, they must adhere to the URI rules. So there can't be spaces and there can be only specific characters. And if there was a mistake in there in your base data, it will not show in this window, but it will show in the window of GraphDB. Right, I did there. It up to see it. So this is the GraphDB desktop kind of window, and here it shows lots of messages. And if you get an error in this window, it will tell you down here in that window, it will tell you which of your URIs was wrong, which makes it possible for you to debug it, because if not, you will probably not find it. Okay, then so this was this generic CRM, which I believe we developed together with Steve Stead, which I believe is extremely useful in experimenting with mappings, and Milena will go to that point as well. But if you have real data, then I want to show you how we did it for an excavation data, and that's the excavation data of the excavation sample. So that looks, the structure is exactly the same. You have your input data, and we have two examples there, one for a survey and one for an excavation sample. And we have the SQL scripts and the RDF creation. I will show you a little bit the structure, so to get an idea how to structure real data, kind of. So what we did is we created 9 different sheets, which could be 9 tables, of course, and they contain specific CRM classes. So we have the sites and features together with the objects, with observations, with argumentation, stratigraphic units, information objects. And I just want to show you one of this, the E27 and the S20, how it would look like in OntotextRefine. So I go to OntotextRefine, make a new, close that project. Make a create project. I go directly to URI files. I don't run through the process now. I take the S20 excavation sample. So here the data looks like that, and you see what we did in these excavation samples. In the fields, there are the identifiers of an S20 and also the identifiers, for example, of the types. And the relations, they are encoded in the mapping. So the relations are not really here the properties are not defined in the Excel, but the properties are defined in the mappings. You see that in a moment. Create the project. I go to the RDF mapping. Upload the JSON. The JSON is again the RDF creation, OntotextRefine models, the S20 mapping. So this is how a typical mapping would look like if you map your data. I have my S20 URI, which is, I define a subclass because I differentiate between a site and a rigid physical feature. And if I want to make a double instantiation, I just put here another class. I can do that. This is the OntotextRefine mapping interface. And then I say it consists of, this is the URI of the material. and so on. And then it consists, is approximated by a geometry and so on. So if you look at that, this is describing my site with its labels and with its identifiers, nodes. It overlaps with this E53 with a place. So I put on the relation to the place. And here I make is composed of relations between these things, or an S4 URI relations to an observation, and relations to the person or to documents. So this is how a mapping looks like, and the process would be exactly the same. I go on save, go on my Sparkle query editor, generate my query, I get my my service identifier, and then I go into the Sparkle query window, make a new Sparkle, copy it from the RDF from the Sparkle here. We have here Sparkle 2. It's a little bit excavation sample Sparkle. And here I have my S20 mapping. That one here. The identifier here. And let's have a look. It worked. And then I got much more information now. And if I look and explore, I got probably a new graph, this new graph with the S20 features. And now Milena is going to show, did I miss something in the presentation? Let's switch to the presentation. Yeah, of course, they are with the identifiers. This is your sovereignty of the identifiers. They have to relate between these different sheets that you have. Wrong way. Milena, floor is yours. And we switch because it's easier.
Oh, thank you, Gerhard. Getty. Hello, everybody. We are already sharing. Okay. So some of you, I have seen some faces that I already knew. So some of you have seen this. We tried to test this generic CRM or RDF creation with data from different projects. So I'm just presenting a very short example from a project that I'm working on, and it's an interdisciplinary project, linguistics and history. So some very different data is the one that we are working in this case. Our main sources are two state registers. So from late Middle Ages in the county of Tyrol, from the 14th and 15th century, what today is Tyrol in Austria and South Tyrol and Trentino in Italy. These documents, they contain ownership from the landlords, and they listed all their properties and the obligations people had to pay or taxes lists. So it gives an overview of the economic situation and social relations at the time. Or that's what we are trying to see. We have digitized these documents in Transcribus, and we want to extract the information that's for our investigation relevant, which are persons, the possessions, the places, the levies, so the payment forms that there are listed, rights that are given. This is made in spreadsheet forms. We have one table where the whole document is exported from Transcribus, and we do we tag here possessions, time spans or time indications, levices, granted rights, persons, and so on. And after that, we have several tables with more specific information from some of the tags. In the case of persons, we give identifiers, and we also standardize the names because these are all written in early High German, which is a bit different from the German from today. So we standardize in a modern writing way. And we have relationships about, for example, between people, if they are married to someone or they have children, a social status like serf status is the only one we have. Origin, if this person is mentioned as coming from a certain place, and so on. And from the places, the same thing. Also, we give identifiers and a standardized name and mother name, and some geographic information, coordinates, and so on. So these are the tables where we came from. And then with these entities that we tag that are relevant for us, we did a mapping how these relate to each other. Do we have? Yes. So in this case, we have here an example. It's a coppersmith, which is mentioned here, and he has been given from the landlord a farm, and he has to pay every year 30 pounds a sheep, and he has to care for horses. And he has the right to give this farm to his heirs afterwards. So here is our person. Here's the information we had from the other tables. And here we have this relationship with the landlord about the farm and the levies that he is paying every year. So this is for us to organize our information, and we translate this table into this generic CRM table. So we see here a short example. Here it's this person, the coppersmith, and here we see all the properties or the connections to the social status, serve, the profession, the type, well, male, and the origin, which is here. It's shown in the graph, and it's exactly this part of the mapping. So the mapping help us to put it all in this table, which is a great form for us that we are experimenting in this case with ontologies to test how these properties work, how these classes work in our data, if we are going the right way, or if we have to look for other ontologies for further information. So I'm going to show you some examples of this data. It's all, the graph is only kind of about this paragraph and the extra information that we have. For example, it's now this bond that connects the coppersmith with the landlord. Here we can see it, all the bindings that it binds to persons with a possession. Yeah, and you can follow it always with the property. That's how you can read the table to see which is connected with what. And the thing that Gary was saying, the opportunity to use RDFstar. In this case, we have only 3, but here are expressed in this table as well. So you can see which properties have one are connected also to a entity further on. In this case, the role of these persons in this tenancy, or the right that this person has over the property. So I think we're coming to the end. I hope you could follow, and actually we're quite excited about this because excellent way to test our data, our material. So we're kind of playing around now.